The second speaker is Dan Rutherford, and he's with the uh, ICCT, International Council for Clean Transportation. He's going to give us a presentation on the impacts from Arctic shipping. It's all yours, Dan.
All right, great. Thanks, Russell. And I'm very happy to be here to talk about some research that my colleagues at the ICCT have completed about the impact of black carbon emissions from ships in the Arctic, and then measures to mitigate those. As a bit of background, I lead the aviation and shipping programs at the International Council on Clean Transportation. We're a research-based nonprofit that advises governments worldwide on how to better control emissions from all of the major modes of transportation. Today, I'll be talking to you about recent trends in black carbon emissions from the shipping sector, why these are an important both health pollutant and climate pollutant, and then walk you through 3 recommendations for policymakers on how to mitigate their impacts. So since we might be time constrained, I thought I'd actually start with the key messages here. What you should come away with today is knowing that black carbon is an important climate pollutant and also a health impact for the Arctic and communities located near the Arctic. You'll learn a little bit more about the magnitude of black carbon emissions from shipping and how they've increased over the past 6 years. I'll walk you through the benefits of switching towards distillate fuels in shipping, away from the current prevalent use of residual fuels like heavy fuel oil. And then I'll talk you through 3 concrete proposals to governments for how to mitigate the impact of these emissions. So let's talk about the magnitude of the emissions first. Black carbon is an important climate pollutant. It's emitted due to the incomplete combustion of residual fuels in marine engines. Depending upon the timescales of the metrics, black carbon is responsible for between 7 and 20% of the total climate impact of shipping emissions. 7% using a 100-year global warming potential, 20% using a 20-year global warming potential. According to IMO's 4th greenhouse gas study, black carbon emissions from ships increased by about 12% from 2012 to 2018. Now, black carbon is not only a climate pollutant, but it's also a health hazard. The solid particulate matter that ships emit, which includes black carbon, were estimated to have caused more than 6,000 premature deaths in 2012 above 40-degree north latitude. Now, ICCT, in its own inventory, estimated that ships emitted about 1,500 tons of black carbon above 60 degrees north in 2015. About 200 tons of that fell within the IMO's limited definition of the Arctic, which is shown in the blue outline on this map. Unfortunately, the black carbon emissions from ships have been increasing even more rapidly in the Arctic than the global average. The left panel on this chart shows how much black carbon was emitted from ships within IMO's Arctic, specifically from heavy fuel oil. That shows a 72% increase from 2015 to 2019. The middle panel is showing the same figure, but from all fuel use from ships in the Arctic. So that's heavy fuel oil, distillate fuel, and also liquefied natural gas. That increased even faster, 85% between 2015 and 2019. And this compares to a global increase of only 8% over that 4-year period. So the big takeaway is that black carbon emissions from ships are increasing 10 times faster within the Arctic than the global average. So what's the quickest and easiest way to control these emissions? Quite simply, it's to shift from the use of residual fuels to distillate fuels, essentially the diesel fuel similar to what are used for on-road vehicles today. And doing so would have a number of benefits. It would reduce black carbon emissions by 50 to 80% relative to heavy fuel oil. It would also enable, it would reduce air pollution. That would be sulfur oxides, particulate matter, etc., without using exhaust gas scrubbers, which increase water pollution as a byproduct of their operation. Distillate would also enable the use of diesel after-treatment technologies, including diesel particulate filters and electrostatic precipitators, which can cut particulate emissions by more than 90%. And lastly, using distillate would reduce both the risk and the expected cost of fuel spills in the marine sector. According to our estimate, cleaning up a distillate spill costs about 30% less than cleaning up an equivalent spill using low sulfur fuel oil, and 70% less costly than cleaning up an HFO spill. So let's talk a little bit about ways that we can mitigate these emissions from the shipping sector. You may have heard that the International Maritime Organization is moving to ban the use of heavy fuel oil in the Arctic. That would have the impact of reducing black carbon emissions from the combustion and also mitigating some of the spill risk that I just mentioned. The challenge is that there are a number of large loopholes to IMO's approach. So the full ban will take effect in 2 years' time, but it has waivers and exemptions that are built into it. So, for example, ships that were purchased after 2010 will have a 5-year exemption from the requirements, and then near Arctic states, including Russia, the US, Canada, Norway, and Denmark, have the right to grant 5-year waivers for their ships operating in their waters. And so as a result, the HFO ban will not take full effect in reality until July 2029. Now, if governments move to not grant waivers to their ships, it would have a significant impact in cutting black carbon emissions. And this chart just shows if countries do not exempt their ships, it would lead to about a 70% reduction in the use of HFO within the IMO Arctic. The large majority of that would come from Russian-flagged ships operating in Russian waters. So that highlights the importance of that country in efforts to control these emissions. Overall, if the full exemptions and waivers are granted, we estimate that the HFO ban would still allow about 3/4 of the HFO fleet to operate in the Arctic through 2029. And the policy would only reduce HFO carriage by 30%, HFO use by 16%, and black carbon emissions by 5%. So you can see that there's a lot of room for improvement if IMO does go and eliminate these loopholes. The second policy that could be refined to control these emissions is in Europe. Under the Fuel EU Maritime proposal, Europe is proposing a goal-based approach to reduce the carbon intensity of marine fuels for ships that are operating to and from its ports. Currently, Fuel EU Maritime does not include black carbon emissions, and a simple step that Europe could take to reduce the impact on the Arctic is to, in essence, require the use of distillate fuels for voyages that are leaving its ports and operating within the Arctic region. And that could reduce black carbon emissions from those voyages by between 50 and 80%. The final policy recommendation is pretty simple. The International Maritime Organization has a series of climate standards for ships that are currently all based on either a fuel consumption or a carbon dioxide basis only. They do not include other short-lived climate pollutants, including black carbon, methane, and nitrous oxide. So this approach has a potential to promote fuels that emit less carbon when burned, but emit larger amounts of these co-pollutants. And as a result, the net climate impact can actually increase from their use. So there is a paper into the next MEPC meeting from the Solomon Islands Pacific Environment and the Inuit Circumpolar Council to reform IMO's approach and do a full life cycle assessment of all relevant pollutants. And this would help avoid some of the unintended consequences I just mentioned. So that's all for me, just those 3 policy recommendations for people to think about as we start to address these important impacts from the shipping sector.